This video will explain how to do triangle congruence properties as a review, and then go over how to do the congruent statements. Now keep in mind from our previous work, you need at least 3 pairs of corresponding parts to guarantee triangles are congruent. Again, minimum 3 corresponding pairs of congruent parts to guarantee congruence. Now 3 corresponding pairs won't always work, but the minimum is going to be 3. Now here's our 4 cases that work. Notice all of them in red use 3 letters because minimum 3 pairs. Side, 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 3 pairs of corresponding sides. Side, angle, side, 2 pairs of corresponding sides and a pair of corresponding angles. Angle, side, angle, 2 pairs of corresponding angles and a pair of congruent sides. Angle, angle, side, which is the last case, which is 2 corresponding pairs of angles and a corresponding pair of sides. Now let's look at how to write the congruent statements based on what we're given here. In the side, side, side example, I need to be able to determine what's sides and what's angles. And the way to look at a picture and tell is going to be where it's at. If it's marked along the edge of the figure, in which case AB it's the edge of the figure, that's a side. Along the edge of the figures are the sides because the sides make up the figure. Now an angle is going to be noted inside the figure. If it's inside the figure, it's an arc, and it's between 2 adjacent sides, that would be an angle. So in this picture, all we have are sides that are marked. In the first triangle, the 1 tick mark is side AB. In the other triangle, it's this segment over here. So we'll say that segment AB is congruent to segment LM. Now we put the bars above it when we write it to denote sides or segments. So AB with the bar above is pronounced segment AB, congruent to segment LM. Now let's go to the double tick marks. Here, segment AC is congruent to segment LK. Let's go to the 3 tick marks. Segment BC is congruent on the other triangle to segment MK. Now all 3 pairs of sides here were marked prior to starting. So we'll refer to those as givens. Givens are things that are marked on the picture prior to us actually beginning. So this is side, side, side. We're ready to write a congruent statement for the triangles. Now when I do this, I can pick any way to name the first triangle based on the letters I'm giving. I could say triangle ABC, triangle CAB, or triangle BAC. But when I write the second part of the statement, I have to make sure the order matches. So here's how I wrote it. Triangle ABC is congruent to triangle LMK by side, side, side. Well, how do I know that LMK is the correct order? Here's how I do it. If I went from triangle A to B to C, let me look at the tick marks. From A to B to C would be 1 tick mark, 3 tick marks, and then the 2 tick marks to take me back to where I started, 1 to 3 to 2. Well, I need to go in the same order in the other triangle. To go from 1 to 3 to 2 is how I got triangle LMK. Now let's try the second example. Here's side, angle, side. Let's start this time with the double tick. It doesn't matter which one we start with as long as we catch our 3 givens. The double tick would be segment AC. In the other triangle, that's segment XZ. Now let's go to the single ticks. Segment BC is congruent to segment ZY or YZ. Now the other piece that's marked is inside the figure and it has an arc. That's an angle. The angle is marked inside the figure between 2 adjacent sides. So here, angle C is congruent to angle Z. The way we'll write that is with the angle symbol, so angle C, congruent, angle symbol Z. Now all 3 of these were given to us at the beginning, so we'll list that they're given. Now I chose something a little different this time. I wrote triangle CAB. From C to A to B is congruent to triangle ZXY, and it's by side, angle, side. Now the way I knew this is I looked at the sides. From C to A to B would be the double tick side, the no tick side, and then the 1 tick side to get me back to where I started. 2, none, 1. So when I match it, I've got to go the same 2, none, 1, which is how I got ZXY. Now the third example, let's mark out what we're given. Let's start with the angles this time. Angle B has a single arc. Which angle is congruent to that too? It'd be angle Y in the other figure. So angles B is congruent to angle Y. Now let's go to the double arcs. Angle A is congruent to angle X. What's the third piece? Well, now it's a segment because it's on the edge of the figure. Segment AB is congruent to segment XY. We have the 2 angles and the side that is in between. That's how I know this is angle, side, angle. Two pairs of angles and a pair of sides that are in between. All right, let's write a congruent statement. Now remember, these were given, and it proves congruence. So I'm going to use triangle BAC this time. The reason I chose BAC, it's arbitrary, but I like BAC because it went from the one arc to the double arc angle to the no arc angle. Now to match the other figure, I got to look and take from the single arc to the double arc to the no arc, which is how I know that triangle BAC is congruent to triangle YXZ. If you get the order wrong, then the problem's wrong because the statement's not correct anymore. So triangle BAC is congruent to triangle YXZ by angle, side, angle. Now the fourth example is also going to have two angles and a side, but it's not angle, side, angle. Here, if you look at the picture, we have two pairs of corresponding congruent angles, but the pair of congruent corresponding sides is not in between. That's why this is angle, angle, side. The side is not between the two angles that are marked congruent. All right, so let's list out my pieces. The single arc would be angle A, congruent to angle Y. The double arcs would be angle B is congruent to angle Z. And then lastly, that third piece is a side. So segment AC is congruent to segment YX or XY. Now when you do a side, it doesn't matter whether you say YX or XY. It's the same side no matter which way you look at it. These were givens. And now I'm ready for a congruent statement. Triangle ABC from A to B to C was one arc, two arc, no arcs. So in the other triangle, 1 to 2 to none, is how I got triangle YZX. I need to make sure my order matches. And this time it's by angle, angle, side. Now I said before, 3 parts doesn't always guarantee congruence. Let's look at the two that don't work. Side, side, angle, and angle, angle, angle do not guarantee congruence. It's possible they're congruent, but it doesn't guarantee it. In side, side, angle, we have two sides, but here, the angle is not in between. That's why it's side, side, then angle. Angle, angle, angle is all 3 pairs of corresponding angles, but again doesn't guarantee congruence. So let's list out the pieces. In the first one, the single arc is segment AB. It's congruent to segment ED. The double tick marks would be segment AC is congruent to segment EF. Now I don't see an angle marked, except I do see the 45 degrees. And I see another 45 degree in the other figure. Well, those are congruent angles. So angle B is congruent to angle D. Even though it doesn't have the mark, 45 and 45 degrees, they're equal angles, measures. All right, so angle B is congruent to angle D. Unfortunately, though, side-side angle doesn't guarantee congruence. So we can't say that they're congruent. The angle is not in between the two sides, which is why this is what it would look like if it was in between. Because it's not there, the best I can say is the triangles aren't guaranteed congruent. I need more information before I could say they are. Now in angle, 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 this is going to be a real easy one to see because you'll notice that it's just the pairs of corresponding angles that are marked congruent. Angle C is congruent to angle Q. Angle A is congruent to angle P. And angle B is congruent to angle R. Now I've got 3 pieces, but there's no sides. These triangles are similar, but they're not congruent. That means they have the same shape, but one can be an enlargement or a reduction of the other, and they're not necessarily the same length. So unfortunately, the best we can say with angle, angle, angle is they're similar, but not guaranteed congruent. Now, once we find that the 3 corresponding parts to prove the 2 triangles are congruent, then we know that really all 6 parts are going to be congruent. If you can prove that you have congruent triangles using your 3 pieces, well then the other 3 pieces also have to be congruent, corresponding to the other triangle. So let's look at an example here. Here, in a previous example with the side angle side example, we went through and proved the triangles were congruent. We were given that segment AC is congruent to segment XZ, we were given that angle C is congruent to angle Z, and we were given that segment BC was congruent to segment YZ. So the triangles are congruent by side angle side. Now once I know that those triangles are congruent, I actually know some more pieces. Now even though the other 3 corresponding pairs aren't marked, once the triangles are congruent, congruent triangles have those congruent parts. So here's what I can also guarantee. Now that I know the triangles are congruent, I know that angle A is congruent to angle X. Those are matched pieces. And I know that angle B is congruent to angle Y. Now there was a pair of sides that weren't marked before, but I know those are congruent also. I know that segment AB is congruent to segment XY. And again, the reason is the congruent triangles have congruent corresponding parts. If the triangles are congruent, that means all their corresponding parts also have to be congruent. Now we can abbreviate this. The way we're going to abbreviate this is this symbol right here. Congruent triangles, arrow to the right, congruent parts. Now let me go back for a minute. How did I know angles A and X were the ones that matched? Well, if you look at the triangle congruent statement, it tells me angle A was the first angle in our statement, so angle X has to be the first angle in the other statement. That's how angles A and X are congruent. Angle B was the second letter, angle Y is the second letter. That's how I know those angles are correspondingly incongruent. Segment AB is the first two letters, which means if I take the first two letters of the other statement, XY, that's how I know those sides are corresponding and congruent. Now, a few other things to keep in mind. Sometimes two triangles are going to share a side. And even if it's not marked that they're congruent, these pieces are guaranteed congruent because anything is congruent to itself. In math, we refer to this as the reflexive property. Now, another thing to be kind of careful about is sometimes in order to be clear about what specific angle we're talking about, we need to use a three-letter name instead of a single-letter name. It's necessary when angles have more than one angle at one vertex. So if you have more than one angle sharing a vertex, you've got to use a three-letter name to be specific. Now here's an example down below where I've kind of used both of these all at once. All right, so we've got two triangles. It's kind of hard to see that it's basically one triangle that's been split down the middle to make two other triangles. And I'm going to prove that the triangle on the left is congruent to the triangle on the right. Now, here's how we do it. In the figure, I see that they tell me that MA is congruent to TA. That's where the double ticks are. Okay. That's this piece right here. Now, to name these angles, I can't use a single letter name. It's not fair to say angle A is congruent to angle A because I don't know if angle A is the angle on the left, angle on the right, or the whole 180-degree angle that makes the whole big angle between them. So instead, I need to use a three-letter name. On the left-hand side, a better name would be angle MAH. The vertex is at A, and the angle goes from M to A to H. And it's going to be congruent on the right-hand side to angle TAH. The three-letter name uses the vertex as the center letter. And that's a better way because it's more specific. Now the piece that's in the middle, I only have two parts that are congruent, but there's a third piece out there. We can see that AH, this piece in the middle, is going to help me to guarantee congruence. AH is congruent to AH, and we say this is because of the reflexive property. Reflexive property means it's a shared side. So we do have enough to conclude that the triangles are congruent. So in this case, triangle MAH, the one on the left, is congruent to triangle TAH, and now it's because of side, angle, and then we have that second side. So it's SAS. All right, thank you for watching this video, and hopefully it helps you to understand.